Welcome to GSD Brainers, the place where curiosity meets discovery, the mesmerized, enigmatic dance of colors known as the Northern Lights. This celestial spectacle, also known as the Aurora Borealis in the Northern Hemisphere, has been a source of wonder and fascination throughout human history. These ethereal lights, weaving and swirling in the night sky, have inspired countless myths, legends, and stories across cultures. The Inuit believed that the spirits of their ancestors can be seen dancing in the lights, while the Vikings believed that the lights are a bridge of fire to the sky created by the gods. In some tales, they are the spirits of the departed, in others a fiery dragon in the sky. Yet, in some cultures, they are a harbinger of doom or a signal of divine favor. From the Inuit of the Arctic to the Maori of New Zealand, people have looked up at these brilliant shifting hues and felt a sense of awe and wonder. But what if I told you that these magical lights aren't just a spectacle for our eyes, but a manifestation of a fascinating scientific phenomenon? The captivating northern lights are a result of a series of scientific events happening right above our heads. Let's start with our main star, the sun. It's not just a gigantic ball of fire, it's also a veritable powerhouse, constantly churning out energy. Occasionally, the sun throws a tantrum, ejecting massive bursts of charged particles into space, a phenomenon called a solar flare. This eruption sends a stream of plasma, known as solar wind, hurtling through the solar system at speeds of up to 1,000,000 miles per hour. Now, let's turn our gaze towards Earth. Our planet is wrapped in an invisible cloak, known as the magnetosphere. This protective shield, generated by Earth's magnetic field, deflects most of the solar wind. However, some particles get trapped and are funneled towards the poles, where the magnetic field is strongest. Here's where the real magic happens. As these particles descend, they collide with oxygen and nitrogen atoms in our atmosphere. Each collision excites these atoms, causing them to light up. The result? A mesmerizing display of glowing, dancing lights in the sky. What's more, the type of atom and the altitude at which the collision occurs determine the color of the light. But there's more to this cosmic ballet than meets the eye. The northern lights are not just beautiful, they're also a visual reminder of the dynamic and complex interactions between the sun and Earth. Earth isn't the only planet with aurora activity. Auroras have been observed on other planets in our solar system, including Jupiter, Saturn, Uranus, Neptune, and Mars. These celestial bodies exhibit similar auroras near their magnetic poles, akin to Earth's auroras. These breathtaking light shows are a testament to the power of the sun, the protective might of Earth's magnetic field, and the delicate balance that exists within our solar system. They remind us of our place in the cosmos, a tiny blue dot in a vast, swirling sea of stars and galaxies. So in essence, these celestial lights are a cosmic dance between the sun and Earth's magnetic field. Now that we know what causes the northern lights, you might be wondering, why do they display such a variety of colors? Well, let's dive right in. Imagine the Earth's atmosphere as a massive canvas, where solar particles are the brushstrokes and gases are the paint. When these solar particles, charged with energy, collide with different gases in our atmosphere, they create the stunning palette of colors we associate with the auroras. Let's start with the most common color, green. Green is usually produced by oxygen molecules located about 60 miles up in the atmosphere. When these oxygen molecules are hit by solar particles, they get excited and emit green light as they calm down. Now, if you see red hues painting the sky, that's also oxygen at work, but this time, it's the oxygen located at higher altitudes, around 200 miles up. These oxygen molecules take longer to calm down after their encounter with solar particles, and when they do, they emit a red light. On the other hand, the blue and purplish colors are a bit more rare. These colors are produced by nitrogen. When solar particles collide with nitrogen molecules in our atmosphere, they can emit blue or purplish-red lights. Nitrogen at lower altitudes gives off the blue light, while at higher altitudes, it's more of a purplish-red. So the colors of the auroras are not just random flashes of light, but a direct result of the type of gas and the altitude at which the interaction takes place. They are a silent symphony of science, a testament to the wonderful interplay between the sun's energy and our planet's protective shield. And remember, these colors aren't exclusive to the northern lights. You can witness this mesmerizing light show at the southern hemisphere too, where it's known as the Aurora australis. So the next time you see a green or red flash across the sky, you'll know it's not just magic, but a fascinating play of gases and solar particles. The northern lights are not just a beautiful spectacle, they have a deeper connection with us than you might think. Imagine a colossal wave of charged particles hurled towards Earth by the sun. These particles, traveling at mind-boggling speeds, are carried by what we call solar winds. When they reach our planet, they interact with the Earth's magnetic field and create the stunning displays we know as the aurora borealis. But the story doesn't end with just the beautiful lights. These solar winds, packed with energetic particles, can also play havoc with our technology. They can cause fluctuations in the Earth's magnetic field, leading to geomagnetic storms. These storms can overload power grids, causing widespread blackouts. They can also disrupt satellite communications, affecting everything from your GPS navigation to your favorite satellite TV show. The aurora lights can be seen anywhere in the world, even at the equator. However, these wondrous lights in the sky could also indicate that the Earth is under severe solar attack. The magnetosphere has two weak spots at the poles, which is why we can see the lights at the poles. However, if we were to see them anywhere else, it would mean that Earth's defense against the sun has failed. That would be a bad day for mankind. The worst solar storm in recorded history, known as the Carrington event, occurred in September 1859. The Carrington event sparked a huge geomagnetic storm that wreaked havoc on technology, causing severe damage to telegraph stations and leading to global reports of strong auroral displays. Telegraph communications around the world failed, and there were reports of sparks showering from telegraph machines, operators receiving electric shocks, and papers being set ablaze by rogue sparks. The Halloween storms of 2003, characterized by powerful solar flares and coronal mass ejections, affected satellite systems, caused power outages in Sweden, and led to aircraft being rerouted. The solar storms also caused spectacular auroras, bright enough to cast shadows from the United Kingdom to Bilbao, Spain, indicating unusual auroral activity in regions not typically associated with the aurora borealis. This event from 2003 was a small solar storm compared to 1859, and that's only what we have recorded. A severe solar storm could result in widespread electrical disruptions, persistent blackouts, and interruptions to global communications. This technological chaos could cripple economies and endanger the safety and livelihoods of people worldwide, leading to a breakdown in essential services and impacting various sectors, from transportation to healthcare. The potential consequences of a severe solar storm hitting us today are dire, with the potential to significantly set back our civilization. As we marvel at the beauty of the northern lights, remember that they are not just a spectacle for our eyes. They are a tangible manifestation of the sun's influence on our planet. They stand as a testament to the intricate dance between the sun and the earth, a dance that shapes not just the lights in the sky, but also the technology that powers our modern world. By studying these lights, scientists can infer the intensity and direction of incoming solar winds. This knowledge is crucial to predicting solar storms and mitigating their impacts. It's like having an early warning system, helping us to protect our technology from the sun's tempestuous moods. So the northern lights, with their ethereal beauty, are not just a feast for our eyes, but also a crucial part of our understanding of Earth's relationship with the sun. That's all for today, folks. For more brain-boosting content, hit that like and subscribe button. Thanks for watching.